So on this displacement versus time graph, we said the slope of the line is the same as the object's velocity. But I think maybe we need to do a little review with slope. How do you calculate the slope of a line? Do we need to talk about that a little bit? How we calculate the slope of a line? Yeah. Okay, so let's pull up some graph here real quick. Okay, so let's say I've got a graph that looks like this. All right, and my object has a slope that looks like that. Okay? First of all, let's review some different things about the coordinate plane, right? This is X, this is Y. What's this center dot called right there? Origin. The origin, and that's where our coordinate points are 0, 0. Okay? If I'm calculating the slope of the line, and actually I'm going to give myself a little smaller slope line here so we can see some better definition with that. So give me just a second. Let's say that my line looks like that. Okay, now we can see some intersection points. Okay? When I'm calculating the slope of a line, does anyone know the equation for that? Or what's the kind of rule of thumb for calculating slope? Okay, no, that's not the slope. That's the equation of the line. Y equals mx plus b is the equation of the line. This m right there is your slope. So how do we calculate m? Rise over run. Right? Is that familiar to you or no? Okay, so rise over run is the same as the change in y over the change in x. Okay, or the same as y final minus y initial over x final minus x initial. So if you are not sure how to calculate slope, that's not something we know how to do yet, or you just don't remember that, I would write that down, right? To calculate slope, slope is m. We're going to take y final minus y initial over x final minus x initial. Okay? So this calculating slope is going to be how we determine the velocity of my object. Okay? And here's why. If this was a displacement versus time graph, then my displacement would be on the y-axis, my time would be on the x-axis. And so that means this would be meters and this would be seconds. So when I calculate slope, I would end up with meters over seconds. Right? That's the same as my velocity. So let's review here slope a little bit. I'm going to pick 2 points along my line, and I'm going to do my best to find points where they intersect, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 1, 2, 3, 4, 5, 6, 7, whatever. Okay, so I see 2 lines. I'm going to try to look for 2 points where they really intersect at clean points. Right there and right there. Okay? When I calculate the slope of my line, I've got to pick 2 coordinate points first. And I've got to label those 2 coordinate points. So the first point right here, what's the coordinates of that point?
3, 4.
Other way around. X goes first, then Y. Okay. How do I label this coordinate point right here? This is a 6. So 9, 6. Right? That's just labeling the coordinate points. I label it X first, then Y second. Are we on the same page so far? Okay, if I'm going to calculate the slope, I want the final point and the initial point. This point would be final because it comes second. This point would be initial because it comes first. So as I'm looking at these, I'm going to take my y final. Right, here's my slope. Y final, which would be 9, minus y initial. Sorry. Y final, which would be 6, minus 3. Right, here's my y values. over my x values, 9 minus 4, and I get a slope that would be 3 over 5. That would be how I calculate slope.
What? Like,
Okay, let's try another one here. I'm going to keep this. Let's try another just slope problem real quick. Okay, here's the, let's say my line looks like this. We're going to pick 2 points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6. Okay, so we're going to try to pick 2 points along that line that we see it really intersect. Here's one, and here's one. Okay, you can pick any 2 points, but I tried to find ones where they really intersect with a coordinate. Okay, so this one, what would I label this coordinate as? 9, 2. And what about this second one? 13, 0, right? Because it's on the axes. So now if I'm going to find the slope of that line, I will take m equals the change in y. Here's my y coordinates, 0 minus 2 over the change in x. X coordinates come first, so 13 minus 9. Okay, so that gives me negative 2 over 4, which gives me negative 1/2. So does it make sense here that my slope came out negative? Yes or no?
Yes.
Isn't my line sloped in the negative direction? Yes. Okay, very good. So now, let's go back to what we were talking about in terms of velocity, right? Me calculating velocity is the same as me calculating the slope of that line. So if it asks me what's the velocity of this object from 2 seconds to 4 seconds, you calculate the slope. So I need you to be really clear about slope of the line equals the object's velocity. Highlight that, circle it, whatever you need to do, but we need to know that on a graph like this, slope is equal to velocity. Okay? Now, I want you to answer this question. What would it mean for us if we had a negative slope on our graph? It's what? It's not necessarily moving down, because we're talking about displacement, but kind of. It's going which way? It's going backwards. It's moving backwards. So it could be down. If something is falling through the air, it could be down, but it's moving backwards. So a negative slope would mean we have backwards velocity. Okay? Or you could just say it's moving backwards. Okay? This is what a negative slope might look like. Yes.
so if it's negative,
If I was looking at a position or a displacement versus time graph, okay, if my x-axis is time and my y-axis is displacement, would my graph ever look like this?
no,
Why not?
Because it's negative and goes up.
Because it's negative? What's negative?
That section.
Yeah? Why can't it go that way?
Because that's positive in a negative section.
My displacement is positive, that's fine. But what's the problematic part?
It starts in 0 now.
Think about what numbers go on this axis here. What are we measuring? 1 second, 2 seconds, 3 seconds. What would this be?
Negative seconds.
Negative 1 seconds, negative 2 seconds. Is that possible?
No.
No. Right? You can't have negative time. So there's no way for these graphs we would ever see a graph anywhere on this side of my coordinate plane. Right? I could have a graph that looks like this. Right? 1 second, 2 seconds, 3 seconds, 4, whatever. But this just means I'm walking backward. Right? But time is still moving forward. So that still works. Okay? All right. The graph that I've showed you here is someone that's moving forward at constant velocity, right? Constant velocity because it's a straight line. So we want to calculate what is this person's velocity? right? Let's calculate what it is. Okay, on the y-axis is displacement. And we're going to say that it's measured in meters. Time is on the x-axis. We're going to say it's measured in seconds. Okay, so if it asked for the velocity, what's that really mean I'm solving for? Mathematically, what am I going to solve for? Slope. I'm going to find the slope of the line, right? Because we said velocity is the same as slope on these graphs. So when it asks for velocity, I need to calculate the slope, okay? So I pick any 2 points on the line. It doesn't matter if you pick the very beginning, very end. It makes no difference what points you pick, okay? So let's just pick the very first one and the very last one we see. Okay? What would the points of the very first coordinate be?
0.51.
Nope. This point right down here, what would it be?
0.
0, 0. Right? It's at the origin. So 0, 0. What about the second point? What coordinates would it have?
155.
This has 2.5 and 5. Okay, so I come calculate the slope of this. And I look at my change in y. My y coordinates come second. So that says 5 minus 0 over my x coordinates. 2.5 minus 0. Which gives me 5 over 2.5. And that gives me a velocity is equal to what? What happens when I reduce that? What's that math?
Just 2.5.
2. Right? Because 5 divided by 2.5 is 2. And I get 2 meters per second. How do I know that my units come out at meters per second? Well, my y-axis was measured in meters. So that means this is meters. This is seconds. So that's how I get meters per second. Kind of looking at the motion itself. So what happens on this slide if I have a horizontal line? What would it mean to have a horizontal line? For example, from 7 to 12 seconds. So first I've got to figure out, well, where's 7 seconds on this graph? Okay, here's 5, 6, and 7. So that means 7 seconds starts right here. And 12 seconds, here's 10, 11, 12. There's 12 seconds. Does that make sense how I found that data on that graph? So what does a horizontal line mean? Yeah, Eduardo. That's right. That's right. This would mean I'm standing still. Okay, because from 7 to 12 seconds, my position or my displacement stays at 2 meters. It does not change. So if I stay at 2 meters for 5 seconds, that means I'm literally standing still. My position is unchanging. Okay, so what's that also mean about this time frame? 16 to 18 seconds. What am I doing? I'm stopped. What about from 19 to 20? Nope. From 19 to 20, right there, that little section at the end. I'm stopped, but I'm also where? Where am I at? No.
Like where you began.
I'm where I began, right? Look at this graph right here. I started at position 0. Okay, whatever place we happen to call position 0, that's where my graph started, because here's where my graph starts, right here. And let me get a different color. The graph starts here and stands still. Does that, right? But I started at whatever position we named 0. This just so happened for me to end up back at that same location. Had my graph ended up here, I would have ended up 2 meters from where I started. But I didn't. I ended up here exactly where I started, coincidentally. So let's talk through what's happening in the motion here. So from 0 to 2 seconds, what am I doing? Am I moving or no? No. I'm standing still. My position is unchanging for those first 2 seconds. Then what am I doing here to here? I'm walking backwards, right? right? I'm going backward from my starting location. Then what do?
Walk forward.
I walk forward. And do I pass my starting location on the way? Yes. Okay. Then I stand still. Then what do I do from 12 to about 14? I walk backward. Now, can you tell, am I walking backward slowly or quickly? Quickly. I'm walking backward quickly. How do I know that? Right. Okay. So we can look at how steep the slope is. Okay. So let's say, I want you to write this down. A steep slope means that our object is doing something fast. Okay. And a shallow slope means that we're doing something slower or slowly, however you want to say that. Okay, slower or slowly. Okay, so if I look at these two different time frames, okay, I'm moving backwards here and I'm moving backwards here. So in the first segment or the second segment, which one am I moving faster during? When I'm walking backward, am I walking backward faster there or there? First or second? Second, right? It's got a much steeper slope, okay? Then here to here, what am I doing? Forward, then I do what? Take a break, then I walk, which way? Forward, and then I take a break. So how do I know I'm walking forward or backward? Has to deal with your slope, okay? Because a negative slope means negative velocity, okay, or backward. Positive slope means positive velocity or forward, okay?
And neutral?
And this horizontal means I'm standing still. I'm stopped. Okay? I'm not walking at all. All right, let's find we're going to calculate. Oh, no, not on this one. Let's walk through this one. What's happening from 0 to 1 second here? Yep, I'm standing still. Okay, so we're going to write these out. I'm standing still. In this particular example, did I start at what we called the origin? Okay, or whatever point we named point 0. I'm not having to start there. How many meters away am I starting? I'm starting 20 meters away, right? Because at time 0, my location is 20 meters. So whatever we're calling the starting point, I'm 20 meters from there when I start my timer. Okay? From 1 to 3 seconds, here to here, what am I doing?
Slowly walking forward.
I'm going forward. From here to here, what am I doing?
Oh.
I'm standing still, right? I stop because my position does not change for that second and a half. And then finally, in my last part of my motion, what am I doing? I'm moving backwards. And can you tell? Am I going to be moving forward quicker than I moved backward? If I look at these two lines, can I tell which one is steeper?
Are the same.
I think the one going backward is a little bit steeper because I can tell I covered 20 meters in only a second and a half, whereas here I covered 20 meters in 2 seconds, right? So going backwards, I went a little faster. Now that's a little more for us to look at, but I want you to be able to see the trends there, okay? All right, so looking at the same graph, what is my velocity from 1 to 3 seconds? What's my velocity from 1 to 3 seconds? What does this mean I'm going to have to solve for? The slope. Okay, so that's how I look at this graph. I need to find the slope of my graph from 1 to 3 seconds. So here to here. Okay, if you like to do you normally just teach it rise over run? Like I went up 20 meters, 20 more meters over that? Is that how you usually do it? Okay, that's fine. We can look at it that way too, okay? So if I look at calculating slope with rise over run, I went up 20 meters from 20 to 40 and over 1. I went up 20 and over 1. So that means my velocity would be 20 meters per second. Right? Is that easier?
Yeah.
Perfect. Okay, then do it that way. Okay, this line intersected our points very easily. Okay, so if I'm looking at calculating slope that way, I went up 20 meters, because that's the distance here to here, and I went over only 1 second, because I went from 1 second to 2 seconds. Up 20, over 1, right? So that means my slope or my velocity there is equal to 20 meters per second. Agreed? And it comes out positive because my slope here was positive. Okay, my second segment of my line is a little more difficult to see because I'm not running into an exact coordinate cross here. Okay, so what I could do is just take the starting point and the finishing point here and here. 4.5 and 60. And then 6 and 20. Okay, and go ahead and calculate slope that way. So 20 minus 60 over 6 minus 4.5. Oops. Negative 40 over 1.5. And that gives me a value of negative 26.67 meters per second. Okay, and why does it come out negative? Why does my velocity come out negative? Yeah, because I'm going backwards. So our value here should match the slope of our line. Okay. All right, on the next slide here, I want to answer any questions before I have you try one on your own. Tell me what questions we have. All right, on the next one, I want you to calculate the velocity of the object at all three of those sections of the graph. So for part A, I want you to find the velocity. For part B, I want you to find the velocity. And for part C, so you're going to have three different answers here. I'll try to kind of show you where these intersect at. Okay, that point goes to 40 seconds. This point goes to about 80 seconds. And this point goes at about 10.